Hi there, welcome back. In our previous lesson, we focused on the three-way switch. Today, we have a very short lesson for you on a different type of switch that has to work with the three-way switches. I am Mr. Spence. The objectives for today's lesson are you'll be able to differentiate between a three-way and a four-way switch. Identify the parts of a four-way switch. Determine plausible uses of a four-way switch and give the color code for a four-way switch. So we have gone through single pole switch, double pole switch, three-way switch, and now we are on the four-way switch. Key features of the four-way switch. Four-way switch is used to turn on or off a light from three or more locations. Yes, you may say to yourself, how can one switch control a light from three or more locations? Well, firstly, let's look at it. It has four traveler inputs, two at the top, two at the bottom, right? But it must now be installed along with two three-way switches. So the four-way switch forms an additional location of control for a circuit. We learned previously that three-way switches must be connected in pairs and they provide two locations for control. Adding a four-way switch to that combination creates three locations. If you want more than three locations, all you have to do is increase the number of four-way switches you add between the three-way switches. It's quite simple. And as we look at the configuration in a few slides to come, you will see how easy it is to mount four-way switches between three-way switches. So let's look at the parts of this four-way switch. From basically looking at this, it reminds you of the double pole switch, but we will see the difference between the four-way switch, the three-way switch, and the double pole switch. So as we can see, the common parts, the mounting ears, the mounting strap, traveler terminals, and a key feature is that on the toggle, there is no on or off designation, as we recognize that because this will be adding to the locations through which a device may be controlled, there is no need to indicate in which direction would be on or off in this switch's operation. So we have seen traveler terminal number one. We see traveler terminal number two. But we notice, and we do not want to confuse ourselves, but when we're looking at the wiring, there's something we have to note. The toggle, and you should notice by now, 6 to 32 mounting screw, grounding terminal, traveler terminal, and finally your last traveler terminal. Now, as you could have remembered from our discussion on double pole switches, it would be incorrect if we chose to connect these two traveler terminals on the same side together, or these two traveler terminals on the same side together. We must see this four-way switch as being divided into two parts, with one section known as the input and the next section known as the output. Now, it does not matter which side you use as the input or which side you use as the output. So therefore, it is not marked line or load, as you would have remembered the double pole switch was marked line or load. It simply means that when you are connecting the four-way switch, if you want to use these two terminals as your input from one set of from one side of the three-way switch, then you connect both of these terminals back to that three-way switch. Then if you want to use, then you must use these remaining two terminals to connect to the opposing three-way switch. You will see as we look at the wiring diagram. So here we have one lamp controlled from three locations. The source is at the lamp. Typically, we will wire the three-way switches the way we know how. The only difference is that the four-way switch now will find itself in the middle. So our source comes and we feed the first three-way switch. Then we will take the two traveler terminals from that three-way switch, and instead of going directly to the next three-way switch, we will now connect it to the four-way switch. So we will send it to the top of the four-way switch, the first two connections. Then we will take two travelers from the bottom of the four-way switch and send it to the next three-way switch. From that section, we will now feed the switch feed back to the lamp. Simple, isn't it? This is one of the most simple switches to connect, to provide yourself with an additional location for control. Now, as I said before in the previous slide, if I wanted to add 4 locations, 5 locations, 6 locations, all I would have to do is establish my three-way switch on one end as my input and my three-way switch at the opposing end as my output, and between there I will install as many four-way switches in the same pattern as this one. So it is quite simple. And remember, none of these switches have on or off designation. Well, of course, you know that our keyless receptacle or lamp only uses switch feed and neutral, and the neutral comes directly from the source. Keep in mind that the neutral wire never interferes in the control process, because the purpose of the neutral wire is to form a return path for current to flow. So the current enters the circuit on the black wire and goes back to the circuit breaker on the neutral wire, which makes the circuit complete. Let's go back one. As we can see, our schematic diagram of the four-way switch control with the source being at the switch is just direct, with three-way switch number 1 here, three-way switch number 2 here, four-way switch in the middle. You have two traveler terminals connecting to the top, two traveler terminals coming from the bottom connecting to that switch. The neutral goes straight through to the lamp. The pictorial stays the same. So it's quite simple. Once you understand the principle by which the three-way switches operate, the four-way switch is a walk in the park. Now let's look at what we learned today as we recap. Four-way switches are used to create an additional point of control for devices. Four-way switches must be mounted between a pair of three-way switches. Four-way switches have 4 traveler terminals, which means that only blue and green wires are used for four-way switches. We cannot neglect to emphasize the importance of the green or the brown wire on switching circuits. Green wires or ground wires are connected to the main grounding rod that is installed on most or all, not most, on all residences to filter out excessive current that flows. This will prevent short circuits, it will prevent electrical fires, or it will prevent one from getting an electric shock if they come in contact with any metal box that is servicing an electric circuit. Let's keep that in mind. And that's the end of our lesson today.